So for the next part, we're going to look at a new family of functions. We're going to look at radical functions. The radical functions will be inverses of the exponential functions. So first of all, we'll look at what a radical looks like. A radical will look like where we have what's called an index, a radical symbol, and then a radicand. So this number here, kind of on the little shelf of the radical symbol, is called the index. This is called the radical symbol. And this number underneath the radical is called the radicand. So we'll use those vocabulary words throughout this section. So when we look at a couple different examples, if we have this square root of 64, you have to know that because you've used this so much, you might have forgotten that this really means the square root of 64. We want to know what squared equals 64. That's the answer to that question. So what the square root of 64 is it's just 8, because you square 8 to get that. So what if we did a larger one? What if we did, for instance, the fourth root of 625? So this is asking the question, what to the fourth power is equal to 625? We might have to work on that a little bit to figure that out, but if you put 5 to the fourth power, you get 625. So the fourth root of it as a radical is equal to 5. So we're going to be working with other indexes than just the 2, which is implied if there's nothing listed there. We'll keep working with that. So we want to talk about what are called principal roots, especially because of when we have an even index, we could have, for instance, negative 8 squared to equal 64. Well, this symbol, we want it to be a function, so we want only one output for it. So this symbol means you get one answer, and it's called the principal root. The principal root is that you get the one answer for it. If it's even, if it's an even root here, you're going to get the positive answer. So like, for instance, if you take the square root of 49, that's going to equal 7. Take the positive for this, because if you know that when we've done, for instance, this equation, x squared equals 49, when you take the square root of x squared, you get the absolute value of x is equal to 7. And so when we did this, we got x equal to plus or minus 7. So you do get two answers to this equation. What squared equals 49? Well, because the square root of x squared is equal to absolute value of x, you get both the positive and the negative 7. When we're doing these square roots, only take the positive. You only want one output so it can be a function. So notice that that's not an issue when we do, for instance, if we do x cubed is equal to 216, x is equal to 6, there's no plus or minus to it. So if we do the cube root of 216, that's just going to equal 6. It is going to be one answer, but it'll be the positive answer for it. All right, so let's go ahead and do radicals and exponents. Talk a bit about that. Just so you're aware, this will be a new idea for most of you. And the new idea is that if we take this radical, which is the nth root of a, and we want to write it as an exponent, this is a new rule to know that the nth root of a equals a to the 1 over n power. It equals a fraction exponent. So for an example, if you had, for instance, the third root of 8, that's equal to 8 to the 1/3 power. Now you could do that on your calculator, and it would tell you that the answer to that is just a 2. It would give you that answer for it. That gives us an advantage now of being able to use the exponent to also be able to evaluate this on our calculator. All right, just another example. So this is example 1, example 2. If I did the square root of 121, just a reminder, what's implied is that on this little shelf here, which we haven't put a number, this is implied to be the square root of 121. So when you write it as an exponent, it's going to be 121 to the 1/2 power. You used 1/2 or 0.5, and that would give you an 11. All right, so that's what you want to make sure you make a connection between the radical notation and the exponent notation. All right, another basic that we want to do is how we simplify with and without a calculator. Just a reminder, your calculator rounds things. So if we want to do things exactly, like if we wanted to do the square root of 72, just a reminder, you've done these before. You want to look for a perfect square that goes into 72. Well, 36 goes into 72. So I make this square root of 36 times the square root of 2. Square root of 36 is equal to 6 times the square root of 2. And that's our final answer. This is the exact answer. It's an irrational number. That decimal will go on forever. If you were to do this on a calculator, so if I did this instead, this is without a calculator. If I did it with a calculator, the square root of 72 we could do, you will get a number, but it will have to be rounded because it's a number, a decimal that goes on forever. So that would be the decimal rounded to 2 decimal places, but just remember this is rounded, not exact, as part of that. So when asked for an exact number, you've got to leave it in radical notation. When you're asked to round the answer, you go ahead and use your calculator to get that answer. All right, the last thing we want to do to introduce radical functions is talk about their basic graphs. And we'll get into this a little more later, but just so you're aware, the basic graph of a radical function, if it has an even index, if that number is a 2, a 4, a 6, an 8, the basic graph of it will look like this. It kind of looks like half of a sideways parabola, which it actually is, and we'll talk more later about why that is when we look at the reflection of an inverse function over y equals x. With an odd index, though, because you can take the root of a negative number with an odd index, its graph will look like this. It will come in, it will have that same look over on this side, but will also look like this on the other side. It looks similar to what would be the inverse of, say, x to the third, because this is x to the 1/3. It has the other half of it going in the negative direction because you can take the root of a negative. So these are the basic information about radical functions as we introduce them, about what you do with the notation and what you do with the graphs of them.